Hello and welcome to this video, which covers the contents of the third exercise on the third assignment in our course Competition Policy and Strategy. This exercise, of course, is on the topics of economies of scale and economies of scope. In order to approach this topic, we are within this exercise faced with three different industries or three different markets, however you want to call it. In each of these industries there is one single firm, and we don't really care about them being a monopolist in this case, because we are going to look at their cost functions. In the first industry, which is described in task A, we know that, that the firm that is operating in this industry has a cost function that follows this. So it reads 900 plus 3q plus q squared. We are now asked to determine the interval of output quantity q for which this firm shows economies of scale in its production. Okay, so we are talking economies of scale. And of course, the first thing we should do is have a brief recap on what economies of scale actually is and how do we measure it. Okay, so economies of scale, or in short EOS, in production exist if the average costs, AC, as a function of the output quantity, of course, decrease in the output quantity. Okay, so if with every additional unit produced, the average costs over all units produced decrease. So how do we find out whether or not we are in a situation where this is the case? Well, we can simply have a look at the first derivative of the average cost function, of course. Because we are literally asking, is the average cost function decreasing? Which is equivalent to asking, is the first derivative of the average cost function negative? Okay, so let's calculate the first derivative of this average cost function and have a look at whether or not it is smaller than 0. Okay, so that is maybe the most intuitive approach to this. We can, by stating this problem and going through this step by step, we can learn even more about this. And that is, well, if we state the first derivative of the average cost function, we then can rephrase it to this expression, right? So we have the first derivative of the cost function times the quantity minus the cost function itself, all derived by q squared. And what you will notice is that the first derivative of this cost function over here is simply the marginal costs, okay? So by rearranging this expression, we can tell that the marginal costs need to be smaller than the cost function divided by q. And cost function divided by q, of course, is the average cost all over again. Okay, so what we know by this expression is that we have a decrease, we have economies of scale, or in other words, we have a decrease in output, a cost decrease in output quantity in case the marginal costs are smaller than the average costs. Okay? And this should make sense intuitively, right? Just consider a situation where you have some amount of average costs given some amount you have produced so far. And in this situation that you are right now in, so you have produced some amount Q, and this sum amount of Q comes with a certain average costs. And now you know the next unit you will produce has lower costs, which is equivalent of saying the marginal costs of production are smaller than the average costs of production of everything you have produced so far. Well, then what would happen if you choose to produce an additional unit? Well, if the marginal costs of production are lower than the average cost of production of all things produced so far, then of course the average cost of production will decrease by choosing to produce one additional unit. Okay? So that is what is happening here on an intuitive level. As long as the marginal costs of production are smaller than the average cost of production for a given Q, well then we are in a world where there is decreasing costs, where there is well then we are in a world where there is economies of scale. Okay, now there is two additional terms that we'll need to define. The first one is size advantage. Size advantage means that the average costs decrease in Q. So basically, the larger the firm is, or in other words, the more the firm produces, the lower the average costs. Okay, so basically we are saying, by saying a firm has a size advantage, we are implying that there is economies of scale. If there is size advantage, then the so-called scale economy index takes a value which is larger than 1. The scale economy index, again, is defined as the fraction of average costs divided by marginal costs. Now we spent a few minutes talking about the relative size of these two values, average cost and marginal costs. And we figured that in a world where there is economies of scale, we know that the marginal cost is smaller than the average costs. And then of course something bigger divided by something smaller equals a value that is larger than 1. All right? So this is nothing new. This is just another way of saying we have economies of scale, and it still relies on the same two quantities, or same two values, namely the average costs and the marginal costs. Okay? Just by putting them into relation, we get one single nice number, and in case this number is larger than 1, well, this of course tells us that average costs were larger than marginal costs, and that of course tells us that we have decreasing average costs in Q, or in other words, economies of scale. Size disadvantages, of course, is the exact opposite, right? So it means that the average costs increase in Q rather than decreasing, which implies that the marginal costs actually are larger than the average costs. And again, looking at the same fraction we discussed earlier, which is called the scale economy index, SI, well, we then would expect that this fraction takes a value that is smaller than 1. All right, with this out of the way, let's have a look at the first exercise. Again, as a reminder, we know that the cost function is defined as 900 plus 3q plus q squared. So, what do we need in order to say whether or not we have economies of scale? Well, we discussed it now multiple times. We need to look at the relation between average costs and marginal costs. So let's first start with the average costs. Let's calculate average costs. And for this specific function, well, dividing this cost function by q gives us the average cost, of course, and this average cost then reads 900 divided by q plus 3 plus q. The marginal costs, of course, is nothing but the first derivative of the cost function with respect to parameter q. So we calculate this first derivative of the cost function, which gives us 3 plus 2 times q. So what we now know all the components that we need in order to answer the question. And as a reminder, it said, determine the interval of output quantity for which this firm shows economies of scale. So what we are asked to do is show for what interval of q is this expression true. Because if this expression is true, we have economies of scale. Right, so we simply substitute for this expression the terms that we just calculated a few lines above, and we solve for q. And we will find out that, right, so we substituted these two expressions and then we solve for q, and we find out that this saying AC is larger than MC is equivalent in this specific case to saying Q is smaller than 30, right? So this expression is true if this expression is true. Right, so we now know the answer to this question. We do have economies of scale because average costs are larger than marginal costs as long as Q is smaller than 30. And that is the answer to our question. Alright, so we have economies of scale for an interval of Q lower than 30, and by logic of the context, the actual interval of Q then of course is Q needs to be element between 0 and 30, simply because we always assume that it is not possible to produce any negative amount of any output good. Okay, good. The logic behind this is that we have a fixed cost digression for relatively small production quantities, right? You see, we have fixed costs, and with any additional unit produced, we see that this fixed costs is split between more units of production, right? So the average costs should decrease due to this fixed cost digression. Fixed cost digression, but only for a relatively small production quantity, because what we also see is that we have relatively large variable costs. Relatively large variable costs, of course, only for large values of Q, because we have this expression. This Q squared is really what drives very large variable costs in case Q takes larger values. All right. Just to put this into perspective, for a value of 30, of course, we already know that the fixed costs are exactly as high as the variable costs. So, in this specific case, we do see the advantages of a fixed cost digression, at least in the beginning, but then after a certain amount, and this certain amount, we already know it's 30 or 29, after this amount, actually the exponential increase in variable costs outweighs the fixed cost digression. Okay, so this kind of production function, we would argue, is a typical cost function for a market with relatively strong competition. Why? Because, well, for each individual firm, it cannot be profit maximizing to produce a vast quantity, but rather we would expect in this kind of market, in this kind of industry, a lot of relatively small firms. Right. And in this case, the level of the final point is level of the minimum efficient scale determines the market structure. Minimum efficient scale in this case means that, well, it's the amount of quantity that a firm needs to produce in order to be efficient. All right? And in this specific market, we see that this value is rather small. All right, to the next industry. Next industry, similar setting. There is one single firm, and we again know the production function of this firm. It reads 70 plus 4Q. And we are now asked to show that this firm has economies of scale in its production for any Q larger than 0. Okay, so same approach that we just followed through. We have again a look at the average costs, so cost function divided by Q, and the marginal costs, so the first derivative of the cost function with respect to Q. And then we put these two into perspective. We ask the question, well, for which interval of Q is this expression true? Is the average costs larger than the marginal costs? Or in other words, because if average cost is larger than marginal costs, we of course have economies of scale. All right, we know average costs, we know marginal costs, so we can simply plug these numbers in and see that this expression, so the existence of economies of scale, is equivalent of saying Q is larger than 0. Which can be interpreted as, well, for any Q that is larger than 0, we see that the average costs are larger than the marginal costs, So for any value of Q that is larger than 0, we see economies of scale in this industry. So what we see is the larger the firm gets, the cheaper it can produce. And this kind of scenario we would usually consider a natural monopoly. So a world where it is profit, where the biggest firm is at the same time the firm that can offer the lowest price. Okay, so the productive efficiency that is producing at the lowest costs possible is achieved for one single supplier, so a monopolist. So again, just to reiterate, this kind of market that is characterized by a cost function which resembles the general structure of this industry, we would consider a natural monopoly. All right. We are now asked to interpret or to compare these results with the results from task A. Well, in task A, in industry 1, we saw increasing marginal costs because of this exponential growth in marginal costs. So the intuition was that the costs of production in this industry are lower if there is multiple firms that produce individually a lower quantity, in comparison to a world where in this industry there's only one big firm producing all the quantity. In contrast to this, we see the exact opposite in industry 2, because as we just discussed, we have constant marginal costs, which means, and fixed costs, to make the story complete. So as a consequence, we see that a single firm is actually producing at a lower average cost than multiple small firms. Okay. Towards the third and final industry. In this industry, we are now considering two goods. So this cost function depends now on the output quantity of good A and the output quantity of good B, QA and QB respectively. And we of course find both quantities in the definition of the cost function. So the cost function reads 2 times QA plus QB minus 3 times QA times QB. So for the first time we actually have multiple products in a single industry. This is of course needed when we want to have a look at economies of scope. So we are asked to check whether there are economies of scope for this company in the production of good A and good B. Let's first briefly talk about economies of scope. What we mean when we're saying economies of scope is there is a combined, that the combined production of multiple goods, or in this case 2 goods, is cheaper than separate production, right? That's why we call it economies of scope. So the generalized condition would be, for generalized in the sense that we abstract from A and B, but we are still in a 2-product world. We compare a situation where there's 2 firms that produce 1 good each. So there's one firm only producing the first good and one firm only producing the second good. And now, if there is economies of scope, then this separated production should yield total costs of production which are larger than producing both of these quantities together. In this specific case, so we are looking at, when we're looking at this specific case, we are considering exactly this situation. So we are adding the cost of producing some quantity of good A and 0 quantity of good B, plus the opposite, so producing 0 of good A and some quantity of good B, right? And compare this with producing any quantity of A and any quantity of B, okay? So this first expression, 2QA, results by assuming that QB takes a value of 0, which of course means that this and this expression just cancel out of the cost function, right? And the same logic applies for the second part of this comparison. So QB is simply the result of assuming that a firm hypothetically produces some amount of QB but 0 of QA, which then again results in cancelling out this part of the cost function. Okay, so we are now comparing these two hypothetical cases where the firm produces only one good at a time with the situation where the firm can produce both goods at the same time. Okay, and now we can rearrange this. We can bring all of the QAs and QBs on one side and can thereby show that that this expression is larger than 0. All right, so, and by showing that the left-hand side is larger than 0, we have shown that this expression over on the top over here is true, right? So, this expression is true for any situation where this, let's call it 1. This 1 expression is true for any situation where this 2 expression is true. And for a world where firms can only produce non-negative quantities, so any positive amount of good A and good B, this of course is always true. Right, so we have shown that a firm that is faced with this cost function shows economies of scope. We went through all of this math and logic in order to find this, but we can confirm that our result kind of makes sense, right? Simply by having a look at the cost function. Because we have this last term where we are subtracting something that depends on the product of both firms, right? So the production costs appear to decrease when there is some combination of these two goods. This already, of course, gives it away that there is economies of scope in this scenario. All right. Now, finally, we are asked to interpret our results. So, economies of scope. In this, these economies of scope facilitate the existence of multi-product firms and concentration by allowing a cost advantage in one market by participation in another market. That is exactly what we are seeing here now. We said that this is one single industry, but you can imagine a situation where good A is sold in one market, good B is sold in another market, but by being active in both of these markets, this firm that faces this kind of production or cost function then has a cost advantage over the competitors that are active in only one of these markets, in only market A or only market B. All right, so when we want to evaluate this kind of situation, of course, the minimum efficient scale is very limited because the minimum efficient scale only tells us the scale at which the production in one single market is efficient. But in order to assess economies of scope, we of course have to consider both markets or all markets that are in the scope of this firm.